Hi everyone, in this video we're going to talk about the functional groups called the amines. Now amines can come in a variety of different flavors, if you will. I've drawn several of them out here. This first example, amines all contain nitrogen, by the way. But this first example, notice that the nitrogen only has one carbon group coming off of it. Now I did put the lone pairs on here. Those will become important when we talk about physical properties. So because this has only one carbon substituent, this is called a primary amine, which we would designate as a 1 superscript 0. This amine, notice it now has two carbon groups, an ethyl group and a methyl. This would be called a secondary amine. Likewise, this one here, it does have two methyl groups and an ethyl, so it's got three carbon substituents. This is called a tertiary. And also amines can go to this sort of structure where we actually have four carbon groups attached. Notice now, this has a positive charge. These are a little bit rare, but they do occur. This is called a quaternary amine or a quaternary ammonium ion. And they are permanently positively charged because these methyl groups and this ethyl, they can't come off. So those are kind of an unusual thing that amines can do. When it comes to nomenclature of amines, we're going to keep things pretty simple. The nomenclature of amines can get quite complicated very quickly. And in general, there's the IUPAC naming system, but there's also common names. And it turns out that most organic chemists, biochemists, pharmaceutical chemists, they tend to use the common nomenclature rather than the IUPAC, even though it does exist. So we're going to just keep things quite simple here. So if I had a simple amine like this, a primary amine, you count the number of carbons. All right, so this has 3 carbons, so it's a propane derivative. But we would just list this as propylamine. Now in the IUPAC nomenclature, this would be called propanamine. But I have to admit, I've never used that word. Most people I know don't really refer to that using the IUPAC nomenclature. So you just take the carbon chain and add a YL ending, and then tack the suffix amine. So these are going to end in the suffix amine. Now if you had something like this, okay, I'm drawing the same thing as our secondary amine here. This is a secondary amine. What you would do is you'd find the half that has the longer chain. That's going to be the parent chain. So this is an ethylamine derivative. But then it has this methyl group attached to the nitrogen. So what we do is we list a capital N methyl, okay, to show that the methyl group is attached to the nitrogen, and then list it as ethylamine. Okay. Now, in some cases, this N could be dropped off. If you just listed this as methyl ethylamine, you'd probably draw that structure as well. All right. And then lastly, if you had 3 carbon groups attached to the amine, becomes essentially the same thing. If you had different groups attached, you would list N, comma N, and then list the different groups there. But let's just do a very common one. Let's use or do the nomenclature of this amine. Notice that I have 3 ethyl groups coming off the nitrogen. So this is just simply called triethylamine. Okay. Lastly, what I'll say is that amines can sometimes be a substituent off of a larger group. All right. So let's say we had a cyclohexane ring with an NH2 group as a substituent. Okay. So this substituent is called an amino substituent. Okay, so that would be listed as an amino substituent. Okay. And this could be called aminocyclohexane. All right. I will mention, though, going back to the common nomenclature, this could also be just called cyclohexylamine. Okay, those would be the same compound. In general, most organic chemists and biochemists tend to use the common names, and these are basically listing the alkane chain with a YL ending. But I did want to point out that for larger biomolecules, if you have an NH2 group, kind of like an alcohol is a substituent, this could be called an amino substituent. All right, let's just talk briefly about the physical properties of amines. One of the important physical properties you'll encounter if you ever work with amines is they smell particularly bad. Okay. They often have an odor that resembles sort of rotting carrion or rotting flesh. They're just not very nice to smell. So that's definitely one physical property. They also are a little less polar than alcohols. So because it has a nitrogen in its functional group, nitrogen has a slightly lower electronegativity than oxygen. Oxygen has an electronegativity of about 3.5 on the 4.0 scale, whereas nitrogen's about 3. So they are definitely a little bit less polar. And because of that, they tend to have lower melting points, boiling points, and solubility relative to similar alcohols. Okay, let's take a look at why that might be. So if you look at, let's say, a simple amine, let's say propylamine. Okay, so you notice that, actually, let's do a different one. Let's do methylamine, or I'm sorry, let's put a methyl group there and a hydrogen. So we'll look at methylpropylamine. Notice that this hydrogen right here, it's attached to nitrogen, so it's not going to be quite as polarized a bond. So when you form a hydrogen bond to this, okay, let's say to water, okay, that hydrogen bond does exist. However, it's going to be a little bit weaker than a similar hydrogen bond. Let's say we looked at an alcohol. Okay, this hydrogen bond to water. Okay, because it's now involved between the hydrogen of the alcohol and water, because this is a more polarized bond, it will tend to be stronger than an NH bond. So in general, we can say that OH hydrogen bonds are stronger than NH hydrogen bonds. And again, that just goes back to the fact that nitrogen is a little bit less electronegative than oxygen. Last thing I want to talk about when it comes to amines is that amines are bases. So if I have a simple primary amine, let's use propylamine as my example. If I treat this with an acid, let's say we treat it with HCl. HCl is a strong acid. Amines are what are classified as weak organic acids. And the reason that they're acids, or I'm sorry, I misspoke there. Amines are classified as weak organic bases. The reason for that is that they can accept a proton from HCl. And the way that happens is that the lone pair of electrons on the amine can come over and pull off the acidic proton of HCl. And let me just put my lone pairs on HCl. When that happens, the bond between HCl will break, and the electrons between the hydrogen and the chlorine will go over and reside on chlorine. So what you end up getting then is this. You get an NH3 group. When nitrogen has 4 bonds attached to it, it has a charge of plus 1. Now, the chlorine that's then released, because it's now going to be chlorine with 8 electrons, or a Cl- anion, we're just going to pair that up with our positively charged ammonium group. So this now forms a salt. All right. So if this molecule is called propylamine, when we protonate it using HCl, we change this into an ammonium ion. Okay, so this would be propyl ammonium chloride. We won't worry too much about the nomenclature of these, but basically you would name this as an ammonium ion, and then you list out the counter ion, in this case chlorine, like that. All right, now one of the things that I want to finish up with is when you take an amine, which may not be very soluble, so for example, if I take the compound like this is called aniline, by the way. That's probably a compound you'll want to know the name of that structure. It's a benzene ring with an amino substituent. This is not soluble in water. Okay, it's got just the regular amine there. However, if I convert it into its ammonium ion, okay, so if I treat the aniline with HCl and convert it into the ammonium ion of aniline, this now becomes soluble. Okay, so this one was not soluble, whereas the salt becomes soluble. So sort of like what we saw with the carboxylic acids, when we convert carboxylic acids into the salt, they become soluble. Similar types of things happen with amines. If we convert them into the salt, it increases solubility. And this process becomes extremely important when we talk about drugs that contain amines. And a whole host of different drugs contain amines, and this affects the bioavailability and solubility of amine-containing drugs. All right, well, that wraps up our discussion of amines. Good luck with doing some more problems.